Hello and welcome to this course of college algebra where I will be teaching you how to add and subtract rational expressions. So before I introduce problems that are a little more complicated, I want to go back in the past and kind of talk about some problems that we've seen before that we can probably answer in our heads really quickly or not. I just want to go over some rules that are definitely going to show up later. So let's take a half plus a half, which we know is a whole. But the reason we get there is because we add the numerators together to give us 2, and we keep the denominator the same to give us 2 again, and that gives us our number 1. And this is because something called the LCD, which is the least common denominator. And basically what we're trying to find is a common denominator that is divisible by the terms in our original problem. Now, these are the same, so we can just carry this out, and it's very simple to find our answer. But when it's not the same, we have to find the LCD. So here we have 2 and 4. They're not the same, so we need to find, or we need to list the multiples of 2 and 4, which I'll do really quick here. And 4, 8, 12, 16, and so on. Now I can keep going with both of these, but I can already see what the LCD would be. So we're looking for the lowest denominator, which we have 4 and we have 8. However, I'm going to use the 4 because I want to make this as simple as possible. So that's the one that I'm going to use. So I'm going to go ahead and rewrite my expression here, and I'm going to keep the 3/4 because that doesn't change. However, this changes, and it changes because we multiplied 2 by 2 to give us 4, and now I'm going to multiply 1 by 2 to give us 2. And now I can carry out this problem here to give us 1/4. So this method still rings true even when we're working with variables and harder problems, and I'll show you that in a little bit. So now we're going to work through some expressions that have variables in them. So let's look at this first one, and don't feel overwhelmed when you see the x and the y. I'm going to explain that in a little bit. So what I want to focus on is the 3 and the 5. We're still looking for the LCD, and I can list those out for you. If I was doing multiples of 3, it'd be 3, 6, 9, 12, 15. And for 5, it'd be 5, 10, 15, 20, and so on. So I'm going to look through the list, and I see that they have 15 in common. So I'm going to keep that in mind as I'm doing this problem. Now, for the x and the y, I want you to know that we're not going to be repeating any variables when it comes down to the least common denominator because we want to keep this as simple as possible. So when we do find a common denominator for all 3 of these terms, they're only going to have one x and one y, and I'll show you why now. So one thing I want to do is, of course, get a 3 into these terms here. So how am I going to do that? And as well as an x. So I'm going to look at this first one and say, well, this definitely needs a 3, so I'm going to multiply it by 3 because that denominator needs a 3. But it also needs an x, so I'm going to multiply it by x as well. Then I'm going to look at this next one and say it doesn't need an x because there's already an x there, but I will multiply it by 3. So I'm going to rewrite it now. This first one stays the same. Oops, sorry. And plus 12x over 5y times 3x. And I'm going to keep that just to make things as clear as possible. And then minus 3 over 3xy. So the reason why I kept the 5y there was to show you that I need to also distribute it. I need to, distribute the 5y into these into these fractions here. Or really, I should distribute it into this one. So this one needs a 5y because I see there's a 3x, but this problem here has 5y times 3x. So this definitely needs a 5y in the denominator. However, this one only needs a 5 because you can see that it already has 3xy. It just needs a 5. So I need to multiply through for these terms, and that's going to give me 10y over 5y multiplied by 3x plus 12x over 5y times 3x, and then minus 15 over 5y multiplied by 3x again. And I can simplify that and just say 15 xy or yx. And then I can finally carry out the numerator because the denominators are the same. So I'm just going to carry that out now and see that it's 10y plus 12x minus 15. And that's my answer. I'm not going to combine any of these terms because they are not like terms. So for this next one, it's a little bit trickier. We have here x squared minus 16. Now this is the difference of two squares. What I want to do is factor this to see if it shares any factors that this second term has. So I'm going to see what it will look like when I break it apart. And in case you don't know how to separate or how to factor a difference of squares, one way you can think of this is if I rewrote this one here is x squared plus 0x minus 16. It's the same problem, it just has a placeholder 0x. And then I see what adds to 0 and multiplies, if you can't see that, x, and multiplies to negative 16. And that's going to give you x plus 4, x minus 4. So I'm going to rewrite this now to x plus 4, x minus 4, and then plus 2 over x minus 4. So now I can see that they do share a factor. It's the, it's not that one. It is the x minus 4. So really all that needs to change is this side needs to be multiplied by x plus 4 so that they can share a common denominator. So I'm going to carry that out now. I'm going to rewrite this one, just carry it down. And I'm going to add it to 2 times x plus 4 over x plus 4 times x minus 4. Now I can go ahead and carry out the numerators because they have similar denominators. And that's going to be x minus 3 plus, and I can just go ahead and distribute this, plus 2x plus 8. And then I can carry this out, this problem out, and say that 2x plus x is 3x. Positive 8 minus 3 is positive 5, all over x plus 4, x minus 4. And that's going to be your answer. Okay, now it's your turn. Go ahead and try these problems and then come back to see the answers. All right, so for this first one, I wanted to find a common denominator, and I could see here that there was a 2x and a y. So all I did was I started first with the y, and I went ahead and multiplied 3y over 2x by y so that there was a y in the denominator multiplied inside, and this is what I got, the 3y squared over 2xy. And then I went ahead and multiplied this side by 2x so that there was a 2x in the denominator. And so I got 3y squared over 2xy plus 10x over 2xy. Now that these are the same, I can go ahead and add the numerators. And this was my final answer. For this next one, I could see that this could be factored, so that I can find out whether or not they share a factor, and they do. They share the x minus 2. So I didn't have to do anything to this side because there was an extra x minus 2, so I did have to multiply this side by x minus 2. Sorry, I don't want to hide that plus sign there. So I went ahead and multiplied this side by x minus 2, so that I also had another x minus 2. Now that the denominators are the same, I went ahead and subtracted x minus 5, x plus 2, x minus 2 from x minus 5. To make this simpler for myself, I FOILed. And if you don't know what FOILing is, please go to my previous video. And I got x squared minus 4. Now, before I subtracted, what I like to do is go ahead and distribute the negative. And that ended up giving me, oh, I didn't write it there, so that ended up giving me negative x squared plus 4. And then I subtracted that from x minus 5. I had a negative x squared, like what you see here. The x and the, there was nothing else but the x, so I kept that plus x. And then I added negative 5 and positive 4, and that gave me negative 1. And this was your answer right here. Thank you so much for watching. Please leave a like and subscribe so you can see some following videos. Can't wait to come back to you guys. Thank you.